This is the second video in a series about solving problems related to exponential and logarithmic models. So we're going to look at the second example. In a research experiment, a population of fruit flies is increasing according to the law of exponential growth. After 2 days, there are 100 flies. After 4 days, there are 300 flies. How many flies will there be after 5 days? This is on page 259. So in this particular problem, they did not give us an equation, but they did tell us that the growth follows the pattern of exponential growth. So we can use the exponential growth model, which is y equals a e raised to the bx, where e is the constant, a is our starting amount, and b is a increasing rate, or decreasing if it were population decay. But in this case, it's growth. We don't know what a and b are, but we do have pieces of information. We do know that after 2 days, there were 100 flies, and after 4 days, there were 300 flies. So those are x and y coordinates, and we can plug them into the equation to get two equations. So first we would have 100 equals unknown e to the b times 2. And then in our second equation, we would have 300. We would have 300 equals our unknown a, e, which is a constant, and b to the fourth this time. So now I have two equations with two unknowns, so I can solve it as a system of equations. In this case, it's not a linear system, so I'm going to have to do some substitution. I can't use elimination. I probably could use a ratio if I wanted to, actually, but that doesn't totally help us. So let's rearrange our green equation. So we're going to isolate a by dividing by e on both sides. So this is 100 e to the 2b. That's the value of a. Now we can take this and substitute it into our second equation to solve for b. So we have 300 equals 100 over e to the 2b times e to the 4b. And this would be basically the same as if I had 100 over x squared times x to the fourth. So the x's don't disappear, but what does change are the exponents. So in this case, the 2b and the 4b, I would subtract them because that's the law for exponents when you're dividing, and I would have 300 equals 100 times e to the 2b, because 4b minus 2b equals 2b. Okay. Then in order to continue to solve for b, I'm going to divide by 100 on both sides. So now I have 3 equals e to the 2b. b is my unknown, and it's part of the exponent. Hopefully you recall from the last lesson that to get your exponent out of the exponent, you're going to use your inverse property. So you're going to take the log of both sides. In this case, that's the natural log. So we need the natural log of 3 is going to be equal to the natural log of e to the 2b, but natural log of e to the 2b is just 2b. And then we would divide by 2 on both sides, so we have natural log of 3 over 2 is equal to b. Okay, so now that we know what b is, we can go back to our original population and we can plug it in to that green equation. Did I say population? Equation. Original equation. So we have 100 equals, we're going to leave A as A, because again, now we're solving for A. We know what B is, but we're solving for A. E to the 2 times natural log of 3 over 2 powers. What happens to those? They disappear. So you have 100 equals A E to the natural log of 3. But recall, if you raise an exponent, if you raise a base to the log of the base, then you just get the thing. So this value right here ends up just being 3, because e to the natural log of 3 would be 3, which means we now have 100 equals 3a, divide by 3 on both sides, and you get 33.33, rounding to 3 digits. That's the value of A. Okay, so we have the value of A here. And if we go back to our value of B here, if we put that into our calculator, we get 0.549. And we're going to use that number because that makes more sense in an equation. So now we can replace the values in the original equation with A and B. So now we're back to y equals 33.333 e to the 0.549x power. Okay, still not done. But what we've done is we've written the equation that models the population growth of these flies. The original question, though, however, is how to find the number of flies after 5 days. Well, X represents days, so now we go to our CAS and we type in all of this stuff raised to the 5th power. And when you do that, you end up getting approximately 520 flies. Okay, part of your homework is number 37, so maybe you should go try that one right now.